Welcome, ladies and gentlemen, boys and girls, to the Structural MD Podcast, Episode 10, Material Jetting. Hard to believe we've made it this far with Episode 10. Also, I apologize for the circus introduction. We are not going to the circus. We're here to learn about 3D printing. So, real quick, just a couple of housekeeping items. If you need the show notes because you're driving or you want to review the slideshow or you want to see my email, ask questions, what have you, see the videos, look at pictures and so forth, you can do that at structural-md.com/P010. So that was it. That's the only housekeeping item, keeping it nice and simple and moving right along. So like the other previous episodes, again, we're going through a process of 3D printing material jetting, so this will be a shorter episode. So the definition, what is the definition of material jetting if you had to describe it in a sentence or tweet it? Obviously 140 characters. So it's a process by which inkjet print heads are used to jet melted wax materials onto a build platform. This material will then cool, solidify, which will allow layers to be built on top of each other. Like a lot of the other 3D printing processes, there's a lot of synonyms or common terms that are used that also mean material jetting. So these are multi-jet modeling, drop on demand, which is abbreviated DOD, thermojet, and inkjet printing. So how does material jetting work? Let's get a little bit more detail. So material jetting utilizes inkjet print heads to jet melted materials, which cool, solidify, and then layer upon layer is added until the part is built. Obviously, said part is whatever you designed in your 3D modeling software, whether that be CAD, SolidWorks, Inventor, or some other 3D modeling platform. Unfortunately, material jetting does require support structures for overhangs. Typically, this is a different material, one that's a little bit easier to break away or that can dissolve if placed in a bath of a certain solvent. The support material, it's just an additional step in post-processing, and I will definitely make a future episode that really details post-processing. Like I've mentioned in previous episodes, that's kind of the dark horse with 3D printing. The biggest thing that people think is you draw whatever you want, create whatever you want, model whatever you want, click print, and a couple hours later your part comes out. It's not quite that way. There's still a little bit of post-processing that goes on the final end, and when you have support structure, that's just an additional step in addition to the material finish or things of that nature. So one of the unique things is, though, you can use a multi-nozzle print heads to increase your build speed. So obviously, for the sake of conversation, let's say one print head does a cubic centimeter a minute, two would give you 2 cubic centimeters a minute. Now, obviously, there is the law of diminishing returns. You can't just add a bajillion print heads, what a number that is, and have your structure be created in, in like a minute. That'd be called a fire hose, and that's not kind of how it works. So there is a certain limit. But when you do use the multi-nozzle print heads, you have the ability to print different materials. So, let's call them A and B. So nozzle A prints your build material, which is the material you want your part to be made out of. Typically with material jetting, that's going to be a photopolymer or a wax. And then inkjet or printer head or nozzle head B is going to print your support material. So there is a video like the other processes that is linked up in the show notes for you guys to take a look at. They're very short, roughly under 5 minutes at most. It just kind of helps to put a visual context. I can describe this process to you, but it's really neat to see it in action. You see the material flowing out of the printer heads. You see the build plate going down. You see the part being created. And it just helps to give a little bit more context than me trying to verbally describe a very, very visually rich process. So check it out. Link will be in the show notes. So because you can print multi-material parts, you can also do graded material parts. So your part doesn't have to be of one homogeneous material. You can grade it if it's needed to be. So the typical materials, and now in this process, there's only one material really that's used. It's a photopolymer or a wax-like material that's used in investment casting patterns. Now, obviously, my background as a civil engineer, I never really dealt with industrial processes, that an industrial engineer or perhaps even a mechanical engineer would deal with. So I had to Google real quick what investment casting is. So for those of you like myself who don't know, let me tell you. Investment casting is a manufacturing process in which a wax pattern is coated with a refractory ceramic material. Once the ceramic material is hardened, its internal geometry takes the shape of the casting. The wax is melted out and molten metal is poured into the cavity where the wax pattern was. The metal solidifies within the ceramic mold, and then the metal casting is broken out. Again, that is investment casting. So the typical applications are for prototyping, both prototypes for a visual, like you take it to your marketing or your CEO and say, this is what we think the product will look like. And you can also use it to form or fit test products. Again, when it comes to prototyping, you really don't want to have to make a new casting pattern every time you tweak something or realize something isn't quite the way you wanted it to be. It's just going to drag out the product development process. So a lot of industries that have taken advantage of this technology of material jetting are medical, dental, and jewelry. They often use it for a process called lost wax casting. So the last section, as usual, is the additive slices. Still trying to figure out what I should name this part. But anyway, these figures might change whenever you do listen to this episode. I try to find as most up-to-date numbers as I could. Obviously, as technology gets better and people change their businesses and add new parts to their business line, these numbers will change. So as of the recording of this podcast, and to the best of my knowledge, the maximum build envelope was 300 by 185 by 200 cubic millimeters. The minimum feature size, so the minimum thickness one of your features could be, it was 1/10 of a millimeter, so 0.1. And then your typical tolerance, so obviously let's use the prior number for the minimum feature size of 1/10 of a millimeter. Your tolerance on that quote-unquote member would be plus or minus 0.025 millimeters. And then lastly, you can alter how thick your layers are. Obviously, the thinner you go, the better your resolution, the finer detail. And the smallest you can get that layer thickness to be is 0.013 millimeters. Again, the minimum layer thickness for your slicing can be 0.013 millimeters. So again, guys, that's all we got for today. If you have any questions, you're more than happy to email me. My email address will be in the show notes, along with all the other social media links if you'd like to connect. I'm more than happy to field any of your questions, whether it's, can 3D printing help us here? Is 3D printing beneficial for this industry or this application? If you'd like me to come give a presentation on 3D printing, just a really big overview and just to help bring people's awareness to the technology, what it can do, what it can't do, things of that nature, I'm more than happy to. So feel free to reach out to me. I look forward to hearing from you guys. As always, ask questions. More than happy to answer. Until next time, guys, have a phenomenal day.